Okay, group, let's get this started. First things first, we're going to do a quasi free body diagram by putting in our reference system, labeling all the external loads, identifying the possible reactions. So what do we got? We're going to use our traditional rectangular coordinate system with our x positive to the right, y positive up, and we've got our moment around that z positive counterclockwise. We're also going to label our forces. Our external forces, we're just going to call them F1 and F2. We're going to look at our supports. We got one at A and one at B. You can see A here, it's got a roller support, and B is a little hinge. So A is just a normal force, 90 degrees to the surface. B has got something stopping it from falling down and something getting pushed into the wall. So we got a BY. I'm going to assume it's going up. And we've got a BX component that I'm assuming is going to the right. Coo. So we've got three unknowns, three equations of equilibrium in 2D. So we should be laughing, okay? Just by looking at little inspection. If we do sum of the force in the X, we got two unknowns. Sum of the force in the Y, we can solve for that BY directly. If I do sum of the forces at this little A, I can solve for that BX. If I do sum of the forces at B, I can solve for that AX. So I'm going to do both, and then we'll do sum of the force in the X and see if we can solve that, and that it does indeed do equal to 0. And then we should be laughing. Whee! Let's go. So we're going to do sum of the moments at A, solve for that BX. What do we got? We've got our force 1. It's directly in line, so no moment arm, no moment due to force there, but I'm going to label it for fun and games. We got that F2, that 45, causing a clockwise rotation, so positive. Added moment arm of 2 meters. Sweet. Then we've got our BY. Again, it's got no moment arm, but let's just label it for fun. And then we've got our BX causing that negative rotation, that clockwise rotation at 1.5. Whee! Let's see what we got. We'll just fill in the numbers. We've got no moment arm for that F1, so let's not put it in there. We got this F2. We're just going to rearrange this. F2, 45 at that kilonewtons at that 2 meters. We got that all over that moment arm from BX, 1.5. Stuff it in our calculators. And what do we get? 60 kilonewtons. Came out positive, so we guessed the right direction. Happy. Joy. Now, let's do some of the moments at B. And then we can solve for that normal force at A. Sweet. We got, what do we got? This F2, that 45 kilonewtons at a moment arm of 2 meters, causing that positive rotation. Sweet. Then we got the F1 causing a positive rotation as well at a moment arm of 1.5. Coo. And then we've got that NA. I've assumed it's going to the left, so causing that negative rotation. No moment arms for that BX, BY. Everything in equilibrium, everything equal to 0. Just going to rearrange that equation and solve for our unknown, that NA. Got our force 1 moment arm plus our force 2 moment arm. We're going to divide it by that 1.5. Put it in our calculator. Comes out in kilonewtons. 90 kilonewtons, positive. Guess the right direction. Look at us, so smart. Let's do a little check. Do some of the forces in the X. See if our BX and our NA do indeed equal to 30 kilonewtons. So 30 kilonewtons going to the right, positive. BX going to the right, positive. And NA going to the left, negative. And look at this. Magic. Magic. Works out to be 0. Yay. So, Let's see about that. Some of the forces in the Y. We got one more. Equation of equilibrium. We can solve for that By. We got that F2 going down, so negative. Got that By, I've assumed it's going up, so positive. Looky that. Comes out all roses. 45 kilonewtons going up. Happy, happy. Joy, joy. Okay, just a little summary here. Putting in our magnitude and directions of our reactions at our supports. 90 kilonewtons for that Na. 45 kilonewtons going up for that By. Bx going to the right with a magnitude of 60 kilonewtons. Yay.